going to go over pH calculations of Bronsted-Lowry acids and bases, and these are for weak acids and bases. So weak acids and bases don't completely ionize in aqueous solution, unlike strong acids and bases. So here's a diagram. Strong acids and bases fully ionize, as in all of the hydrogen ions dissociate, whereas with weak acid it only partially dissociates. Because weak acids and bases do not fully dissociate, the acid dissociation constant, Ka, is used, and you calculate it using the concentrations of the hydrogen ions, the anions, and the weak acid. And you calculate Ka similar to pH. Recall pH was so it's quite similar. If we do an example, so what is the pH of a 0.5 molar hydrogen fluoride solution at 25 degrees Celsius? The Ka is 7.1 10 to the negative 4. So how we're going to start is we're going to draw our equation. That equals 7.1 10 to the negative 4, as shown by the problem statement. So we're asked to find the pH. So what we can do is we can draw out the equation. So in table formation, we have initial, change, and end. Then we have hydrogen fluoride, and we know it's a weak acid because it's got an acid dissociation constant. So we can add the equilibrium signs, and of course we've got these are all in aqueous solution as well. So say we had so we're given actually the initial concentration of hydrogen fluoride, and we have 0 of this and this. So the change could be, we don't know the change, so we'll just label it X. So when it's dissociating, like a weak acid, we don't know how much is dissociated, so we'll just label it X. X, and 0.5 will go down by X amount. So in the end we've got 0.5 minus X. We have X here and X here. So to calculate Ka, we have X multiplied by X for fluoride divided by the acid, so 0.5 minus X. And so we've got an equation to solve. Because it's a weak acid, we're going to assume, for simplicity of calculations, assume 0.5 minus X is very close to 0.5. Because weak acids only partially dissociate, which is represented by X, we're going to assume that it is very close to X, relatively. So we can then rewrite our equation like this and solve for X. So if we do that, get 0.0188. And what that is, that's the concentration at the end of hydrogen or hydrogen ions and fluoride ions. So this is the concentration. And we know from pH that we can calculate it using this formula. Minus log 10. So we have a pH of 1.72. pH PH is always to 2 decimal places. And that's it.